So I want to sketch the following region and write an iterated integral of a continuous function f over the region. It's just like a problem we just got done doing. The region is different. So I need to think in terms of what is this region? Well, between, let's see, x goes from 0 to 4, so I'm going from 0 to 4. And then y is between x squared and 8 times the square root of x. So x squared will look like this. And then 8 times the square root of x will look like this. And with me going from 0 to 4, I'm kind of curious if really 4 is where they meet, or if this actually meets out here and I'm cutting this off. So I kind of need to figure that out. So what is, see, if I take the square, or 4 squared, that is 16. So this would be at 16 on the y-axis. And this one, square root of 4 is 2. 2 times 8 is 16. So yes, they do in fact meet when x equals 4. The intersection is in fact at 416. So again, this one I could easily do as either a type 1 or a type 2 region. To me, I would leave it as a type 1. This is 8 root x. This is x squared. So I would integrate this function f of xy, whatever that function is, first with respect to y, right? Y-axis, x-axis, up and down is the y-axis. So I'm going to go from x squared to 8 times the square root of x. This is with respect to y. And then x goes from 0 to 4. And there's my solution. I'm just going to clean this up real quickly. There we go. There's my solution. So if I knew what the actual function was that was going to integrate over this particular region, I could just substitute that function in here. Now, if I wanted to do this, I should add to this. This is as a type 1 region. If I want to do this as a type 2 region, I need to think about what's going on here. I have two functions. I have y is equal to x squared. That's what's going on here. And with y being greater than or equal to x squared, that's what told me I'm above it. And then the other function I have is y is equal to 8 root x. And again, because it's less than or equal, that's why I knew I was below this curve right here. Well, type 1 region went this way. If I'm going to think of a type 2 region, I'm going to go this way. So I need to think of these functions as a function of y. So x is going to be a function of y. So if I take this first one, that implies that x is equal to the square root of y. This is root y. And then this one, I'm going to say, okay, I'm going to have, I'll take this in a couple of steps here. I'll have the square root of x is equal to y over 8. That means that x is equal to y squared over 64. And that's going to be this function. So that's going to give me my vertical as such, because basically what we're doing is spinning this around. So this is what I think of as y before. It's now in this direction. So I need to go from here to here. So I would integrate this function f of x, y, whatever it is, first with respect to x. And I'm going to be going from this function, y squared over 64, to this function, which is square root of y. That's with respect to x. And then with respect to y, I'm simply going to go from 0 to 16. Again, if I had a function that I put in here, I could use either of these. I could use this as a type 1 region, or I could use this as a type 2 region, and I will actually end up getting the same result. To me, for this particular function, the way it's set up, this is such an easier route to go.